Hello, and welcome to G Fun Facts Online. What if I told you there's a library at the bottom of the ocean? Not a library with books and shelves, but one made of mud and microscopic fossils, holding the secret history of our entire planet. Beneath the waves, in the crushing pressure of the deep, a gentle rain of dust, pollen, and tiny deceased organisms constantly settles on the seafloor. Year after year, layer upon layer, this process creates a perfect chronicle of Earth's past. Scientists, acting like geological detectives, drill down and pull up long, cylindrical sediment cores, time capsules that can stretch back 140 million years. This incredible field is called Paleo-Oceanography, and it's our key to understanding the ancient dance between our oceans and the global climate. At the heart of this story is the ocean's conveyor belt, massive, slow-moving currents that act like a global heating and cooling system. Driven by differences in water temperature and saltiness, this system moves heat from the equator to the poles, shaping our weather and climate. Any disruption to this conveyor belt can have huge consequences, from triggering ice ages to completely changing regional climates. So understanding its past is essential for predicting our future. But how exactly do scientists read these muddy archives? It's a fascinating multi-step process. First, they look at the grains themselves. Coarse, large grains of sediment mean strong, fast currents, while fine grains suggest calmer waters. By analyzing these layers, scientists can map the history of ocean currents. For example, they've traced the history of the Antarctic circumpolar current, the most powerful on Earth, linking its speed to the growth and retreat of the West Antarctic ice sheet. They also look for clues from land. Sediments eroded from the continents tell us about warmer climates, with more rainfall and melting ice, while rocks dropped by melting icebergs point to colder, glacial periods. Perhaps the most powerful clues, though, come from the tiniest of messengers, microscopic organisms called foraminifera and diatoms. These single-celled creatures build shells from minerals in the water. The chemical makeup of these fossilized shells is a direct record of the ocean they lived in. By analyzing the ratio of different oxygen isotopes in a shell, scientists can reconstruct the exact temperature of the water when that tiny creature was alive. The types of species found in a layer also tell a story, as different species thrive in different conditions, and sometimes the absence of these shells is the biggest clue. About 55 million years ago, a massive carbon dioxide release made the oceans so acidic that shells dissolved, leaving a distinct, dark, shell-free layer in cores around the world, a stark warning from the past. Scientists also use geochemical fingerprinting. For instance, the element neodymium has a unique isotopic signature in different water masses. By tracking changes in this signature up through a sediment core, researchers can map how ocean currents have shifted over millennia. Indian scientists used this to decode 29,000 years of current changes in the Arabian Sea, while others used spikes in mercury from undersea hydrothermal vents to track the powerful Kuroshio current off Japan. This deep-sea detective work has led to some groundbreaking discoveries. We've learned that a key part of the North Atlantic Current intensified 3.6 million years ago, a pivotal moment that shaped the climate of the Northern Hemisphere. We've also proven that the Tasman leakage, a current connecting the Pacific and Indian Oceans, has been flowing for at least 7 million years, a current we only discovered existed less than 20 years ago. The future of this field is even more exciting. New non-destructive analysis gives us a high-resolution, almost year-by-year view of the past. A revolutionary tool called Sedimentary Ancient DNA, or SEDA-DNA, allows scientists to extract the DNA of long-dead organisms from the mud, letting them reconstruct entire past ecosystems. As our planet faces the challenges of modern climate change, the silent stories held within the ocean's depths are more critical than ever. By understanding how the Earth's climate system responded to changes in the past, we can build better models to navigate the uncertain waters of our planet's future. Thanks for tuning in to Fun Facts Online.